Picture this. You're sitting in the exam hall. The clock is ticking down. You open up your Cambridge Computer Science 9618 paper, and right there, staring back at you is a massive multi-part question on software licensing and the Free Software Foundation. Now, let me introduce you to two very typical students taking this exact same exam. First, we have Alex. Alex has memorized every single textbook definition. When Alex sees the question, they overload the page with raw computer science facts, spilling out the 4 freedoms of the Free Software Foundation, but with absolutely zero analysis. Then we have Sam. Sam is panicking about the clock. Sam rushes through the question, completely misses the specific command word requirements, and just writes whatever comes to mind first. When the examiner gets these papers, it's just a sea of red pen marks. Both Alex and Sam failed, not because they didn't know the material, but because they didn't know how to run the marathon. Welcome to this explainer. Today, we're diving deep into the exact strategies Cambridge principal examiners look for. We are going to decode the examiner's playbook together, focusing on energy management and pacing for the long exam hall, so your paper comes back covered in green check marks instead of red ink.
So this brings us to a really pressing question that we need to unpack right now. Why do students, just like Alex and Sam, find multi-step calculations and method marks so incredibly hard? It is a crucial question because mastering this specific process is absolutely essential for your success. These types of multi-step, logic-driven problems appear in literally every single examination series. The examiners have noted time and time again that candidates frequently stumble here. And it's not because they don't know the facts, it's because they treat a complex multi-step problem like a sprint instead of a marathon. They struggle to demonstrate their step-by-step processing. They lose steam, they lose focus, and they drop the easy marks. We're going to fix that entirely today.
All right, let's take a quick look at our roadmap for today. We'll start with core principles, move into the procedural framework, followed by critical analysis, top examiner warnings, and finally, exam strategy. And hey, before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's jump right in.
Section 1. Core Principles. Now, examiners specifically note that top-performing students do not just memorize definitions like our friend Alex did, they exhibit a deeply connected grasp of foundational concepts. If the exam throws a totally unfamiliar scenario at you, say a highly specific, unique dispute over a modified open-source license being used in a commercial product, you don't panic. You map your core knowledge of the Free Software Foundation onto this new problem. This is where we need to talk about the command words. When a question asks you to evaluate, dumping facts won't work. You need to use the PEEL framework. That stands for point, evidence, explanation, and link. You make your point about the software license, you provide evidence from the scenario, you explain how the Free Software Foundation principles apply, and you link it back to the specific exam question. That is what true conceptual understanding looks like in practice.
To build that kind of agility and nail the PEEL framework every single time, you need a solid core architecture. You have to rely on precise definitions and establish causal relationships. But you know what the real golden ticket is? The thing that pushes you up a whole grade boundary? It's cross-topic connections. Principal examiner reports highlight that explicitly referencing connections between different syllabus areas is a guaranteed way to achieve significantly higher marks. Don't treat software licensing as an isolated island. Connect it to data privacy, system architecture, or networking. If a company is using Free Software Foundation licensed code on a proprietary network, how does that affect their security architecture? Building those bridges shows the examiner you are thinking at an elite level.
Section 2. The procedural framework.
This brings us to what I call the computer science success blueprint. The method mark strategy dictates that marks are heavily awarded for your process and clear working, not just the final outcome. Listen to me carefully here. Examiners are actively looking to reward your step-by-step logical sequence. If you just write down the final answer, even if it is perfectly correct, you are leaving massive amounts of points on the table. You literally have to prove how you got there. Think of it like showing your work in a math exam, but for your logical arguments and algorithms. This is how you pace yourself for the marathon. You don't just jump to the finish line, you show every single stride.
So how do we actually do that? Your processing must follow this standardized 5-step sequence. Step 1. Identify the key elements of the question. Step 2. Apply the relevant principles. Step 3. Execute your analysis with crystal clear working. Step 4. Verify your results. And Step 5. Present it all in the appropriate format. Let's think back to our students, Alex and Sam. If we gave them 60 seconds right now to rewrite their terrible answers using this exact sequence, the transformation would be incredible.
Instead of rambling, they would methodically identify the license type, apply the free software rules, analyze the conflict, and present a structured conclusion. If you make this 5-step sequence your default habit, you will ensure no method marks ever slip through the cracks again. It's like magic.
This sequence directly maps onto algorithmic thinking, which is the heartbeat of computer science. Whether you are evaluating a piece of open-source code for a licensing compliance check or testing a block of proprietary code, this rigorous step-by-step approach is completely mandatory. You must show your decomposition, you have to justify your appropriate data structure selection, aim for efficient implementation, and prove your rigorous testing. It is all about making your internal logic totally visible on the page. Stop scrolling! Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. Let's get back to it.
Section 3. Evaluation and Critical Analysis. Let's move to the higher-order assessment objectives, where you really start to separate yourself from the average candidate. Welcome to Challenge 1, the data scan. Imagine you have exactly 60 seconds to look at a complex data table comparing 2 pieces of software. One is distributed under a free Software Foundation license, the other is proprietary. Top-scoring candidates instantly evaluate the underlying algorithm quality by analyzing specific trade-offs. They look at time complexity, how fast and efficient the software processes data. They analyze space complexity, its memory and storage demands, and they meticulously check edge cases to see how the system behaves at extreme limits. If you can scan the data and extract that core trend in under a minute, you have the technical depth to justify exactly why an organization should choose one license over the other.
To make sure you hit those high marks consistently, you need to internalize this evaluative thinking checklist. Now it's time for Challenge 2, Find the Flaw. I want you to imagine a sample paragraph written by Sam. Sam writes, "The company should use the open source software because it's free and better." Boom! Can you spot the flaw? It's losing marks because it doesn't consider multiple solutions, it completely ignores the technical trade-offs, it fails to acknowledge any system limitations, and there is zero hard evidence to justify the decision. The examiners want to see you compare custom proprietary systems against existing open-source alternatives using actual data. You must justify every single decision with hard empirical evidence. That is how you show deep, critical maturity.
Section 4. Top 3 Examiner Warnings. Listen closely here because this is where thousands of students consistently lose marks according to the principal examiner reports. Coming in at number 3 on the examiner's warning list, context ignored. This is when you provide generic textbook answers that are totally disconnected from the specific scenario given in the question. Now, Challenge 3, speed writing. If you have 30 seconds to write one perfect Peel paragraph, and the exam asks about a free Software Foundation license applied to a specific school's network, your point, evidence, explanation, and link must reference that school's network. You cannot just parrot the general definition of the license. The context is your anchor. Ignore it, and you sink.
Coming in at number 2, boundary neglect. This happens when candidates are rushing, their pacing is off, and they simply forget to check boundary conditions and edge cases when verifying their analysis. Let's say you run a calculation, or you're testing a software's constraints under a specific licensing agreement, and you just assume it works perfectly for standard everyday inputs. But what happens at the absolute minimum limits? What happens at the maximum thresholds? Neglecting these boundaries shows the examiner a fundamental lack of thorough testing, and let me tell you, they will dock points for it immediately. You have to test the extremes. And now, the absolute classic trap according to examiners, the wrong tool. This is the #1 reason students drop massive amounts of points. This is when candidates use the wrong formula, the wrong algorithmic structure, or the wrong licensing framework for the specific context of the problem. It shows a fundamental lack of that conceptual agility we talked about earlier. You are basically trying to run our exam marathon while wearing ice skates. You might execute the wrong formula perfectly, you might write a beautiful paragraph, but if it is fundamentally the wrong tool for the job, all your method marks just disappear into thin air. You have to read the question carefully and select the right framework before you start writing.
A major contributor to using the wrong tool is terminology confusion. Look at this comparison. Poor execution happens when a candidate, kind of like Alex, dives straight into an extended response, throwing around complex, undefined jargon, mixing up terms like free software with freeware or open source, hoping something, anything, sticks to the wall. It is messy and examiners hate it.
Top execution, however, is deliberate. It is calculated. Top candidates always define their P terminology precisely before deploying it in their analysis. Define your terms first. It creates a safety net for your logic and proves you know exactly what you are talking about.
Section 5. The Exam Strategy System.
Finally, let's tie all of these insights into a cohesive strategy system you can take directly into the exam hall. To avoid that terminology confusion we just talked about, here is a highly effective memory hack. Use a visual story method. The concepts surrounding software licensing and the nuances of the Free Software Foundation can be, let's be honest, incredibly dry. To lock them into your brain, don't just reread the textbook for hours. Create a vivid, visual story connecting the concepts. Imagine the creator of a piece of software handing over a physical, heavy, golden key to a user, and attached to that key is a massive scroll with specific terms and conditions written in glowing ink. Actively encoding the data into a narrative like this drastically improves your recall when you're under intense exam pressure.
Once you are in the seat, you need to rely on this final execution flow. These are the rules that guarantee top marks. First, deconstruct the question. This is your command word decoding. What are they actually asking? Second, extract the relevant data. Third, select the correct analytical framework. This is where your Peel framework application comes in. Fourth, execute your solution with crystal clear notation so you secure every single method mark. And fifth, present your final answer with the precise, correct terminology. Managing these steps effectively is your time management matrix. This flow allows you to pace yourself, conserve your energy, and confidently navigate even the absolute toughest questions Cambridge can throw at you.
As we wrap up this explainer, I want you to remember this core insight, straight from the examiners themselves. Top-performing students exhibit connected, conceptual understanding transferable to unfamiliar contexts. Your ultimate goal throughout your 9618 studies is conceptual agility, not just rote memorization. You are training your brain to think systematically and critically. Now listen up. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel AC Exams at acexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acexams_IGCSE and click that bell. Don't let another exam pass you by.
So I want to leave you with this provocative question to chew on today. Are you just memorizing facts like Alex, or are you truly mastering the process to secure every single method mark? Take a hard, honest look at your study habits right now. Start practicing your past paper questions using the frameworks we discussed today, focus heavily on your step-by-step process, and watch your performance completely transform. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the exams. Your Cambridge success starts here.